Good afternoon, everyone. Good afternoon. Hope all is well. Hope everyone is doing all right. Hope you had a great weekend since we had a long one. Hope you're ready to go into the next one. All right. So I think everybody is in here now.
Hi, Professor.
Hey.
This is Mrs. Glover, Michelle Glover. I'm on my phone because I'm on my way taking my husband to a doctor's appointment. So I'm here. I'm just going to be on my phone while I'm listening to the lecture. So I just want to let you know I was here so you can count me here.
Okay. Sounds good. Thanks.
Okay.
All right. All right. So we left off here. And that was 1.3, I believe. Just want to make sure. Yeah. So let's. And if I'm not mistaken, we switched that to 2.4. I think the book switched to 2. And I didn't write that one up there. Let me check just to make sure. Come on. Yeah, 2.4. All right, so that's what we're looking at. That's what we're starting today, 2.4, operations on real numbers and evaluating square roots. All right, so when dealing with real numbers, that means we also have to consider the fact that we're going to be multiplying, dividing, adding, subtracting positive and negative numbers. So we're going to look at each operation separately just to make sure we're okay with the rules. So first, we're going to look at multiplication. So when it comes to multiplying your signed numbers, so two positive numbers multiplying together, the result will be positive. Two negative numbers multiplying together, the result is going to be positive as well. Positive times negative is negative, and then negative times positive is also negative. So notice what we have here. If you're multiplying two numbers that have the same sign, the result is positive. Multiplying two numbers that have different signs, the result is going to be negative. Over here is just re-emphasizing that positive 2 times positive 3 will give you positive 6. Negative 2 times negative 3 will give you also positive 6. 2 times negative 3 is negative 6. Negative 2 times positive 3, negative 6. All right, can I scroll up?
So I have a quick question.
Mm-hmm.
I forgot to mention this at the start of class, but so for our homework that was due, which assignments were due? Because I was just a little bit confused on the which assignments were supposed to be due. So I did the first two assignments.
Yeah, so nothing is actually due yet. When we get to a point of closing out a block of work, I think this your due dates for your first test wouldn't be set until after chapter 3. I think I'm doing 2 and 3 together. So that's when we'll set a due date. So once we get closer to closing out chapter 3, we'll put a due date out there. So I think that ends in like 3/6. So maybe around 3/4, 3/5. Once we get to that lecture, then we'll talk about a due date for that block of work. So chapter 2 and chapter 3. So right now nothing's due, but you do want to keep pace with the lecture.
Okay, thank you so much. I just need that to be cleared up because I was really confused on that at first, but
Yep, not a problem. And so I try to leave it open right now, and then and so that allows me to keep a pace with the course, specifically this course. And so maybe we'll have a day that we have a lot of questions, so we don't get as far as, I may have planned. So instead of planning something out, as we progress, we'll look to set those due dates.
All right, got it. Thank you.
Yep, not a problem.
Okay, I got a question.
No, go ahead. I'm just messing. You sound better.
Yeah, she told me yesterday I'm still got a long way to go.
Oh, okay. All right.
But thank you. Okay, you
Yeah.
say +2 and a -3, so that will equal a +6.
He said, no, well, +2 and -3 will be -6. That's this scenario right here.
-3. So, but if you reverse it, it's still like gonna be a negative.
Yep. So these are the two scenarios that will produce a +6. So you're talking about +2 times +3 or -2 times -3. Now, if you're talking about order as far as positioning, that doesn't matter. That still gives you the same result.
Okay, that's what I was looking at.
Okay.
Okay, thank you.
All right, everybody good before we go to division? All right, so dividing is the same set of rules. Positive divided by positive will give you positive. Negative divided by negative will also yield positive. So once again, same signs, positive result. Then different signs will give you a negative result. And so over here in the purple, just examples solidifying what we just said. So +18 over +2 is +9. -18 over -2 is +9. 18 over -2 is -9. -18 over +2 is -9. Now, going back to what Ms. Braxton had mentioned, now we cannot switch the positions of division and expect to get the same number. So 2 over 18 is going to be 1 over 9. So division is different than multiplication. Multiplication doesn't matter. 4 times 5 is 20. 5 times 4 is 20. But when it comes to division, you can't switch those positions. Or you will get a different number. Now the sign thing doesn't matter. Positive or positive, negative or negative, positive result. Different signs will give you a negative result. But I'm just talking about those numbers. You will get something different. So. All right, let me know if you have any questions.
So why is it, if it's a 18 over a -2, why is it a -9? If the numerator is more than the negative.
That doesn't matter with division. When it comes to multiplication and division, it doesn't matter about which one is more, which one is less. It's just about, are you multiplying same signs versus different signs?
Okay.
Now, when you get into addition and subtraction, which one is more, which one is less is going to matter. Yeah.
Okay.
All right. So everybody done with division? All right. Was someone unmuting because they had a question? Are we good? Okay. So addition. I'll say when it comes to division and addition and subtraction, you can think about your money. So first, when you have same signs, you add the numbers and then you keep the sign. If you have different signs, you subtract and keep the sign of the greater, which alludes to what your classmate just mentioned. So in other words, if I have $5 in my account and I add $2, I have $7. But if I'm -5 in my account and I go further negative, it don't go positive, you know. Right. right. I think for those who have some life experiences, because I know for a fact it don't go positive.
Bounce.
So yeah, So negative and a negative, you just add them together and keep that sign. Now, let's say if you have $5 in your account and you spend $2 or charge $2, then you'll have 3 left, positive 3. But if it's negative 5 and you're trying to get out of the red and you add $2 to it, you're still going to be negative $3. So that's how you can think about your money when it comes to adding and subtracting. You once again, same signs, you just add them together and keep that sign. Different signs, you subtract them and then you keep the sign of the greater number. All right. Are we good? Can I scroll up?
Wait 1 second.
Oh no, take your time.
Okay, thank you.
No problem, no problem. All right, then we look at subtraction. The easiest way to deal with subtraction when we start dealing with these sign numbers is to first convert it to addition and then use your addition rules that we just finished talking about. So now the first one, we're used to it. So really, you don't really have to go about doing it that way, but I do want to make sure we're okay and see what I mean by that. So 4 minus 3, we know it's going to be 1. But 4 minus 3 is the same thing as 4 plus negative 3. All right. So always keep in mind that your minus sign, it stays attached to the number that is sitting behind or sitting in front of. So this will always be a negative 3. It's not just minus 3, it's negative 3. Okay, so 4 plus negative 3 is a positive 1. So that helps us in the second one when we have negative 4 minus 3. The reason why is because a lot of times when we do subtraction, we're so used to saying take away, like 4 take away 3 and stuff like that. But negative 4 minus 3, if you go take away 3, we might be prone to put negative 1 as an answer. But if you rewrite it the way it should be seen as negative 4 plus negative 3, that means I'm going to add these two numbers together that have different signs, and the result is negative. So that's why I say it is to your benefit to look at subtraction as addition and follow your addition rules so that you don't have any mishaps. Now, the third one and the fourth one, you don't have a choice because negative to a negative turns positive. So we have 4 minus negative 3 and negative 4 minus negative 3. So those negatives being applied to negatives, I believe we talked about it last class when we dealt with opposites. Negative to a negative turns positive. So that turns into 4 plus 3, which is 7, and then negative 4 plus 3, and that's when we'll get negative 1. Make sure we're okay. All right, can you scroll up? I'm good. All right, so let's walk through a few. All right, so we have negative 3 plus negative 11. And the result is just negative 14. So that's two numbers that have the same sign, add them together and you keep your sign. The next one, we have negative 1/4 plus 1/2. So don't forget, whenever you want to add or subtract fractions, you need a common denominator. So our common denominator here is going to be 4 because we have 4 and 2. So I don't have to mess with that first fraction. But the second fraction, I need to turn 2 into a 4. So I multiply it times 2. And if you do that to the bottom, you have to do it to the top. So that's what I did right here. 2 times 2. Well, not 2 times 2. Well, 2 times 2 in the bottom, 1 times 2 up top. And so that now I have negative 1 over 4 plus 2 over 4. Add my numerators. Negative 1 plus 2 is just positive 1. And you keep that same denominator. Next one, we have negative 10 plus 15, different signs. So you're going to subtract them, then you keep the sign of the greater. So 15 was greater and it was positive, so we have a positive 5 for our answer. Next one, we have negative 8 minus negative 1. Don't forget, negative to a negative turns positive. So that's negative 8 plus 1. Then negative 8 plus 1 is going to be negative 7. Questions? Any questions?
Okay, now say that again.
Which one? You
Negative
talking about the last problem?
Negative 8 plus minus negative 1.
Because what we had is negative 8 minus negative 1. So that negative to a negative that's sitting in front of 1, that turns positive. So that's why we now have negative 8 plus 1. And then from there, different sign, you're going to add those numbers together, but they're different signs. So that means you need to subtract. And then the greater 1 was at negative 8. So your final answer is negative 7.
Okay.
So the next one, 2 minus 7, that's the same thing as 2 plus negative 7. So that goes back to what we're saying is when you're adding different, adding numbers that have different signs, you subtract, keep the greater of the 2. The 7 is negative. So that's why your answer will be negative as well.
You know, Mikey had a little injury there, so you could have hampered his splendid. Mr. Tucker.
Yes, sir.
Is this posted somewhere? You want to have this posted somewhere?
It will be. Yep. After we record it, I'll send it out to you guys.
Appreciate it.
Yep. No problem. I'll try to get that out to you guys before the day is out since there's only one lecture. So, yep. All right. So the next one here, let me erase this. So we have 11 plus 2 minus 7. So we just have addition and subtraction. So we're going to do these from left to right. First thing we should attack is 11 plus 2, which is 13. Just color coding some things differently. And then we have 13 minus 7. And 13 minus 7 is 6. Any problems? Any problems?
No.
Sounds good. So the next one, negative 8 times negative 7. Remember, we already mentioned negative times negative goes positive. So negative times 8, negative 8 times negative 7 will give you a positive 56.
Okay.
All right. So here we have 7 times 1 times negative 2 times negative 3. And so you can just do it from left to right. You can do it in whatever order. Multiplication is commutative, so you can do it in any order. I'm just gonna do 7 times 1, which is 7.
Mhm.
And then I just decided to do -2 times -3, which is 6, positive 6. And then 7 times 6 is 42. If you wanted to do it just from left to right, 7 times 1 is 7. 7 times -2 is -14. And then -14 times -3 will still give you a positive 42. All right. So the next one, I normally trip people up with it, but I already have the answer up. So it's already spoiled. But we have 8 times -2 times 11 times 0 times 9 times 10. So when it comes to this type of problem, a lot of times, as we always do, go left to right, 8 times 2 times 11. But if you look ahead a little bit, you'll see that you have a 0 there. Anything times 0 is 0. So if you look ahead and everything's being multiplied times this 0, then you already know the answer is going to be 0. You don't have to waste extra time and energy trying to figure out what's 8 times 2, then what's 16 times 11 and all the stuff like that. But anything times 0 is 0. All right. Any questions before we go to the next one? Very good. All right.
I'm not.
You say you're not good? What's up?
I didn't get that one.
Which one? The last one?
8, the 2, the 11. Mhm.
Oh, anything multiplied times 0 is 0.
Oh, so you would have said 8 times 0, 2 times 0, 11 times 0.
Well, you got 8 times 2, which is 16, right?
Mhm.
16 times 11 is whatever it is. But then eventually you're going to multiply it times 0, which is just going to be 0.
Oh, okay,
You know what I'm
okay.
saying? So if you look
Okay.
if you look ahead and everything is multiplication, but 0 somewhere in that string, you just know that the answer is going to ultimately be 0.
Okay, thank you.
Yep, not a problem. All right, next one, -9 divided by -3. Negative divided by negative is positive, so it's a positive 3/4. Remember, that has nothing to do with what's greater or anything like that when it comes to division and multiplication. It's just all about same signs or different signs. 20 divided by -4 be -5. Next one, got a few steps to walk through. So give you a chance to get caught up first, make sure everybody's good.
Mr. Tucker,
Yep.
so how you get 20 over 4 over -4? What you did to the -9 divided by -3 equals 3.
Okay.
Which
So now these are two different problems. So
okay. Okay.
yeah. So we were done with this. -9 divided by -3 is just 3. And
Yeah,
then,
okay.
yeah, okay. So you good? Okay.
Yeah.
All right. Everybody good before we go to that next one, that fraction? Okay. So the original problem, we have -1/10 divided by -2/5. Whenever you divide it by a fraction, you have to multiply by the reciprocal. In other words, you have to multiply and flip the fraction. So division changes to multiplication and you flip that fraction. So notice this, first we had 2/5. Now we have 5/2. Okay, sign is still negative. That doesn't change. But we have 1/10 times 5/2 now. So as my arrow suggests, now we can just multiply across. -1 times -5 is +5. 10 times 2 is 20.
Mhm.
And then if you can, you are expected to reduce. And that's what we did right here. 5 in the numerator, and there's also a 5 in that 20, because 20 is 4 times 5. Those 5s cancel. And there's nothing left in the numerator but 1. So that'll be 1/4. Bless you, bless you.
Thank you.
All right, so is everybody good? Now the next one doesn't call for any work, just recognizing the situation. So no calculation, just observation. If there's ever a 0 in your denominator, they're going to assume that you know that it's undefined. You cannot divide by 0. So 0 in your denominator is always undefined. Now it is okay to have 0 in your numerator. 0 in your numerator will always be 0, but 0 in your denominator is always undefined. All right. Any problems? Any problems? All right. So next we're looking at square roots. So when you're looking at something like the square root of 9, that symbol over the 9 is your square root. That we call it the radical. Because as you progress, throughout mathematics, it doesn't have to be square root, but you can do cube root, fourth root, fifth root, and so on. So that's your radical. And then what's under the radical is your radicand. So when you want to try to figure out your square root, you want to ask yourself, what number times itself twice will give us the number under the radical? So in other words, what number times itself twice will give us 9? And that will be 3. So the square root of 9 is 3. So what number times itself twice will give us that number? All right. So square root of 144 is 12, because 12 times 12 give me 144. Square root of 121 is 11. Square root of 49 is 7. 7 times 7 gives me 49. So now when it comes to square roots, there's no magical way of figuring it out. You either know your times tables or you don't. That's really pretty much what that leans on, knowing your timetables. Other than that, throwing it in the calculator, so really that's all it is to it when it comes to square roots. Now, whenever you take the square root of a negative number, that's going to be considered not a real number. So we're not going to get into imaginary numbers and converting them to imaginary numbers, but what you would write is not a real number. Cannot take the square root of a negative. There's no two numbers that will multiply together that are the same number that will give you a negative number. So square root of a negative is not a real number. Any problems? Any problems? So
Explain the fraction.
say again now.
Can you explain the fraction? The
Oh
one.
yeah,
over-
we haven't got to it yet. I'm gonna get there. Yeah. Let me hit this one down here first, then I'm gonna go to that fraction. So now here, I just want to make sure we're okay with the positioning of our negative. Notice that this first one had a negative under the radical, so it was not a real number. But if the negative is on the outside of the radical, then it's not affected by the square root. So you can go ahead and take the square root of 6, but the negative is still sitting on the outside. Okay, so make sure you're okay with that. Make sure you recognize the positioning of your negatives when it comes to these radicals. All right. So is everybody okay with these two, seeing the difference, what you can do, what you cannot do? All right. So
You're
getting to
saying, you're
Hmm?
saying negative 36 is not a real number. What that mean?
the square root of negative 36 is not a real number. So negative 36 is fine by itself, but when you have that square root, you cannot take the square root of a negative number. So if there's a
On
negative,
the inside.
yeah, because it's on the inside, exactly. So if your negative is on the inside of your square root, that's going to always be the response, no matter what the number is. It could have been square root of negative 256. Because it says the square root of a negative, your answer is not a real number.
So Professor,
Mm-hmm.
if it is on the outside, then will that make that -6?
Yes. Uh-huh. Yep. So that negative is still assigned to whatever comes after you take the square root. So yes, your answer will be -6. Everybody good with these negatives? Everybody good with that one? All right. So going to the one that has a fraction, we have the square root of 1/4. Whenever you're taking the square root of a fraction, you can take the square root of each number individually. So the square root of 1, you ask yourself what times itself twice will give you 1. That's 1, because 1 times 1 is 1. And then the square root of 4 is 2, because 2 times 2 is 4. And 1/2 would be your answer.
The picture's in the way, so I can't see it.
A picture?
It's the, I don't know.
You can move it and minimize the, are you talking about the thing that shows everybody?
Yes.
Yes, so at the top of it, you can minimize it with the tinier, or with like the little, the miniature icon, or you can also move it around on your screen by clicking and dragging it.
No, I'm gonna leave it alone. I ain't that good with computers.
So Professor,
Yes.
what happens if it's a number that can't be multiplied by itself?
See, you somewhere, you in a whole other classroom right now.
So don't worry about that right now.
Hey, yeah, don't worry about it. Yeah, we is. I don't even think this class get there. Yeah, I think what you have is going to be something. Whatever you guys get, if I'm not mistaken, you'll be able to take the square root of.
Okay. Just wondering.
Miss Bryson, can you see that now? I know you said the picture was in your way.
Uh-huh.
Okay,
Thank you.
not a problem. But so if you ever come across that, since you got that stuff going on your screen, let me know, and I'll move it accordingly and stuff. And Miss Bryson, let me know when you finish.
Oh, I'm finished.
Okay, cool. Anybody else before we scroll up, get into a little bit of 1-5? 2-5. All right, so let's look at a few properties. And if I'm not mistaken, yep, this is the last section out of chapter 2. So properties are real numbers. I alluded to the cumulative property earlier when we were talking about multiplication. All it's saying is that when it comes to addition and multiplication, A plus B is equal to B plus A, or A times B is equal to B times A. In other words, it doesn't matter what order you do them or multiply them in, you still get the same result. So 4 plus 5 and 5 plus 4 give you 9. 8 times 3, 3 times 8 still gives you 24. Notice that's only for addition and multiplication. If you switch to positions on your subtraction or division, you will get a different number. You know, you can do it, you just have to be strategic in how you do it, but it's not clear cut. So that's why we're just doing addition and multiplication. So you have to do some conversion there. All right, of course, if I move up and you still copying, let me know. Social property, once again, just looking at addition and multiplication. A plus B plus C. So it's saying it doesn't matter what order you do it in or perform an operation, you'll still get the same result. So you can add B and A first and then add C, or add B and C first and then add A. Either way, you'll still get the same result. And so example of that, we have 1 plus 2 plus 3. So if I do 1 plus 2, that'll be 3. Then 3 plus 3 is 6. Or if I do 2 plus 3, which is 5, and then 1 plus 5, I'll still get 6. All right, is everybody good? All right, distributive property. So if you have a number times a quantity, in other words, we have these parentheses or any grouping symbols, you can distribute that number into the parentheses, into each term, multiplying it to each term. So if I have A times the quantity of B plus C, that's the same thing as A times B plus A times C. Or if I have A times B minus C, that's A times B minus A times C. All right, so just an example of that. Let's say if we have 3, and normally this is more prominent or more used when we have variables involved. So that's why I did that here. Because, you know, if we just had a number, let's say if I have 4 times 3 plus 2, I don't need to distribute here. I can just add 3 plus 2, which is 5, and then 5 times 4. So normally something like that, something like just implemented when I have terms inside of my parentheses that I cannot add together. So we'll talk about like terms and stuff, and in a little bit, and that dictates why we can and cannot add them together. But let's just focus on distribution right here. So you would distribute the 3 into the parentheses into each term. So 3 times x is 3x, 3 times 2y, 3 times 2 is 6, so that would be 6y. And then 3 times 5 is 15, and that's a z right there, so 15z. So all you do is distribute what's sitting on the outside of the parentheses into each term by multiplication. Next one, we talked about opposites last class, distributing or multiplying by a negative. All that does is it changes each sign of the terms inside of your parentheses. So that negative applied to 4a will be negative 4a. Negative to the negative 9 will be a positive 9. Excuse me. I would have hit mute if I could have. I couldn't get to the mute button, y'all. Sorry.
Bless you.
Appreciate it. And then the negative to the negative 12 Would be positive 12.
Okay, I missed some of that. Now you said
Mhm.
that's a 4A.
Inside of the parentheses?
Mm-hmm.
Yep, that's 4A minus 9B plus 12.
Okay.
And so when you distribute that negative that's sitting on the outside of the parentheses, the
Mhm.
negative, and so it's going to change each one of the signs that are in the parentheses. So now you have a -4, a +9, and a -12.
Oh, okay, okay. I get it now. I
Yep.
get it. Thank you.
Yep, yep. All right, so the next one. I didn't mean to do that. Next one, we have 1/2 times 6x plus 14 plus 10. Hold on 1 second. Trying to look at something they left out. Oh yeah, they didn't talk about it. Okay. That was this book. Okay. Yeah, we're gonna talk about like terms next section, but they asked you to do like terms in this, and I was wondering why it didn't show up. So they kind of did things a little out of order. That doesn't come before you guys. You guys are all right. So we have 1/2 times 6x plus 14 in parentheses, and then we have 10. So that 1/2 needs to be applied to the terms that are in the parentheses. That 1/2 doesn't touch the 10 because the 10 is not in the parentheses. So be careful with that. So then from there, you're doing 1/2 times 6. And over here, I try to do a little bit of a breakdown as to how you would do that. So that 1/2 times 6 is just going to be 6/2. And then 1/2 times 14 is 14/2. Everybody good? We can simplify. 6 divided by 2 is 3. 14 divided by 2 is 7. And then we have like terms back here, 7 and 10, which is 17, which we'll talk more in detail about like terms in the next section. They kind of touched on it before they even talked about it right here, but we'll get into like terms in a second. All right, questions on that? Any questions? All right. Everybody done with this problem? Can you scroll up? See heads nodding. Okay, good, good. So some more properties. Identity property for addition and multiplication. Once again, that's how we're looking at it. Or those are the two we're looking at. A plus 0, 0 plus A is A. A times 1, 1 times A, still A. So all this is saying that, adding 0 to anything and just leave it with itself. Multiplying 1 times anything will leave you with itself. All right. So inverse property, A plus negative A give you 0. A times 1/A will give you 1. So what can you multiply to a number to turn it into 0, to turn it into 1? And what can you add to a number and turn it into 0? It will be its opposite, and then it's reciprocal. And that is it for chapter 2. So since that closes out a chapter for us, I won't go into anything new, but you know, I'll just give you guys a chance to breathe and give you some space on that. Next class, we will get in 3.1, and we'll start off with like terms and unlike terms, which is what I was alluding to today. But yeah, that's it for chapter 2. So take advantage of the fact that I'm not going into anything new. Get into this stuff, see if you have any questions. And let's make sure we okay going into chapter 3. Before I close, did anybody have any questions, or if anybody try anything, get stuck on a problem? Everybody good? Everybody
I
good?
did.
All right, what you got?
Okay, when we went, you know, when we go in there and be doing the problems,
Mhm.
I think it's like in the 2.2 one. And I tried to send it to you, but I couldn't.
Hold on, let me see if it went through. You said you couldn't though?
Mm-mm.
Oh, that's the wrong email address. Yeah, I got something from you. It came on last night.
Okay.
You tried to send something to me last night?
Mm-hmm.
Okay, yeah, I see it. I can do that for you. And take a picture of it so I don't have to keep going back and forth. And of course, you can let me know if I'm doing something else.
Yep.
So this is the problem, right?
Yep.
All right, cool. So here we have 7 plus 4 times 6 plus 5, the quantity of 6 plus 5, over 3 cubed plus 6. So the first thing you want to do is look at these almost like you have two different problems. You don't want to try to do them together because they you know, because they're not simplified as much as possible on top and bottom, doing them together is just going to be more complicated than it's worth. So let that be green. So come down here and do that one separately. So you want to do what's in the parentheses first, order of operations. So 7 plus 4 times 11. Then 4 times 11 is 44. Then you can go ahead and add them and get 51. All right, any questions on that?
Mhm.
All right, next one we have 3 cubed first. Exponents want to get your attention first. So that means we're going to do 3 times 3 times 3.
27
You got
plus
it.
6.
Uh-huh.
33.
Uh-huh. And that's all you can do with that.
Oh, okay.
Let me see, 3 times. Yeah, that's all you can do with that.
Okay.
Unless it's 17. Let me see, 51, 3. Oh, yep. Nope, we can reduce it. Yep. I thought it was one in there. So this is 3 times 17. This is 3 times 11. 3's can cancel. And then it'll be 17 over 11. Now that'll be a final answer.
I can't see it again.
Oh.
Okay. Okay.
All right.
Thank you, sir.
Not a problem. Anybody else before we close out? Go into the weekend?
Yeah, Mr. Tucker,
Mm-hmm.
I missed last week. Tanja Colville. I wanted to know what I missed. Do I have to look at those videos you sent my email?
Yeah, that'd probably be best because then you'll get the full you know, scope, because I could say some stuff and I might miss some things. But at least that
Okay.
video, it has everything. Just like I'm gonna make a copy of this and shoot that to y'all as well. So
Okay.
yeah, you be able to pause and rewind or do whatever you want to do with it. Yeah.
Okay. Thank you.
Not a problem. All right.
See you next week.
Yeah, you do the same. Take care. See you next week. Y'all have a great weekend. Be safe. Take
You
care.
too.
Thank you.
Thank you.
Thank you.
Well, thank
Thank
you. Take
You
care.
too.
All right.